Here, we define a middleware that determines whether to use the Edge runtime or the standard Node.js runtime for processing requests. It does so by calling the function shouldUseEdge_runtime, which contains the logic to decide the appropriate runtime based on the request details. If the condition is met, we set the node_env environment variable to Edge. Otherwise, we default it to Node. By setting this environment variable, we pave the way for other parts of our application to adapt their behavior according to the runtime in use. After setting the environment variable, we call next to pass control to the next middleware or root handler. This line of code conditionally requires either the HTTP or HTTP2 module depending on the runtime we've determined earlier. If the node_env is set to Edge, we import the HTTP module as it is commonly associated with lighter, more streamlined Edge runtime environments. The HTTP2 module, however, is included for Node.js runtimes that can leverage the advantages of the HTTP2 protocol, providing benefits such as multiplexing and header compression for efficient network communication. The shouldUseEdge_runtime function encapsulates the logic used to determine if the Edge runtime is suitable for a given request. For example, this simple implementation checks the user agent header for the presence of Edge, indicative of an Edge browser. Based on such conditions, which can be more complex in real scenarios, the function returns a Boolean value indicating whether to opt for the Edge runtime. This function can be customized to consider various factors such as the request path, query parameters, or even the geographical origin of the request. Within an API route handling a GET request to API, some route, we branch our logic based on the node_env variable. An if statement checks whether we are in an Edge environment, allowing us to execute Edge-specific code which could involve executing lightweight and faster non-blocking operations favored by Edge runtimes. Conversely, if the environment is not Edge, which implies a Node environment, we drop down to our Node.js specific logic, where we might handle the request in a manner that utilizes the full power of Node.js capabilities, such as making use of robust libraries and frameworks that are not optimized for Edge environments. Finally, we export our configured application with the middleware and root in place. This lets us run the same application in different environments, while still having tailored logic for each. The modular nature of Node.js applications makes it straightforward to dynamically decide runtime behaviors like this, enhancing flexibility and performance optimization across various runtimes.